All right, guys, today we're going to talk about a third way of solving these systems of equations. This is called the elimination method. You know what we're going to do? We are going to eliminate things. This method, also known as the addition-subtraction method sometimes, also known as the linear combinations method, which is kind of what we did yesterday in our Zoom. So here's a nice system of equations. If you wanted to graph this, put these in slope-intercept form and graph them, great. If you wanted to solve for one of those variables and substitute into the other equation, great. If I look at these equations, if I wanted to solve for y and get them in slope-intercept form, one of the things I notice is that the y-intercept would come from dividing that 17 by 5. So my y-intercept would be 17 over 5. Y-intercept here would be -9 over -5. Kind of ugly y-intercepts. I don't always want to graph things. And if I'm substituting, again, I would have to isolate one of those variables. Let's say I choose to isolate the y. Y would equal -2/5 x plus 17 over 5, and then I'd be substituting that into the other equation. Some ugly fractions there. But if I look at this equation, or the system of equations carefully, I notice something. And what I'm noticing is that there's a plus 5y and a minus 5y. Now again, this method is called the elimination method, or the addition-subtraction method, or the linear combinations method. We're going to combine these two linear equations together through addition or subtraction, and when we do that, something's going to eliminate. That's where those three words come from, those three names come from. I'm going to, watch what happens here, I'm going to add those two equations together. 2x plus 6x, well, that's 8x. Plus 5y and minus 5y, those are additive inverses of each other. They cancel out, right? That's 0. It's a zero-sum pair. If I add 17 and -9, I get 8. Look at that. I went, again, from two equations and two variables down to one equation with one variable. We know what to do from here. We divide by 8, and x equals 1. That was really easy. This system of equations, both of those equations in standard form, it's tailor-made to do this method. Piece of cake. I do also, again, need to solve for y. So I'm going to put that 1 into either of those equations, whichever one looks easier. I'm going to get the same answer either way, because it's the solution, the intersecting point of these two lines. So I'm going to take that value for x. It is 1, and I'm going to substitute it into the first equation just because that one looks easier for me. There's no negatives in it, so less chance I'll mess up my signs. 2 times 1 is 2 plus 5y equals 17, and my next step would be subtracting that 2 from both sides. Gives me 5y equals 15, and y equals 3. That was really easy, right? I didn't substitute anything. I didn't graph anything. I just added those two things together. Magic happened. Not really magic. Math magic. So I get, again, x equals 1, y equals 3, which you could also write as that ordered pair, 1, 3. Let's do one more together. In this case, as I glance this through, I notice that it's going to be, if I add these two together, the x's that will eliminate. No big deal. It doesn't matter which one we solve for first. If I add these two together, the 7x's cancel out. I get 3y equals -6, and dividing by that 3, I get y equals -2. And then again, I'm going to substitute into either one of those two equations. Doesn't matter which one. Whichever one looks easier, I will choose again, the first one doesn't have any negatives. I'll choose that one. I need to remember here, I'm solving for y. I solved for y, right? I need to substitute that in for the y and not the x. So 7x plus 2 times -2 equals 10. So that's 7x minus 4 equals 10. And I'm not going to write this out, but I would add the 4 and get 14. 7x equals 14, so x equals +2. And again, if I want to write that as an ordered pair, that's fine. Remembering that it's not the first one I solved for that comes first, it's the x that comes first and the y that comes second. All right, try a problem or two now.